Uh, Good evening to one and all. Myself, Ensai Pranav from Group G366, and the project that I'm currently working on is called Finance GPT. In simple terms, it is nothing but understanding financial Gen AI models. Our project mainly revolves around the world of finance, where we try to build a mobile application that can do three specific tasks. One is it can classify finance documents. Second is it can answer the questions asked by the user, a QA model, and the third is it can summarize and mask any important personal information from a financial document like bank account number, Aadhaar card number, etc. And the technologies used are Flutter, which is a tool that we use to build a mobile application, with Firebase being the database. And GenAI is nothing but it's a combination of all the AI models that we use, like Llama and Florence GPT, or BERT and Vision Transformer, etc. Flutterhooks is brings in a React component into the website where we can interact. We can connect the front end with the back end. And AWS is the Amazon Web Services, which is a cloud platform where we can deploy and host our application. Next is this dataset, which we use to train our BERT model for the question answering task. The dataset looks somewhat like this. Yeah, where this is the pretext, post-text, and the table text, which the collection of the three of them will give us the answer, the context for a particular question. So for this question, the collection of those three will be the answer, will be the context, and the answer can be found out in that context. Using this program, we need to use this program and undergo these steps to finally get the answer, this answer. And this is an ID which is unique for every different JSON object, and that is the data set. Next, we enter into the BERT models architecture, where we try to where we give an input. The input is tokenized and undergoes positional encoding as well, and the final output looks like this. This is the positional encoding class, and the final output looks like this of of embedding dimension 256. It later undergoes multi-head attention, as mentioned in the diagram, in the architecture diagram, and undergoes normalization. And the output again looks the same, but it is context enriched. That meaning the QKB operation has taken place. Next, it enters feed forward mechanism, and and the output never changes. It always remains 256 because every single time we try to enrich or upgrade the values of each vector, and hence it's just enrichment and not changing the size itself. And finally, the output of feed forward is again normalized, and this is seen in the encoder part. The encoder contains a multi-head and feed forward, and the output is returned. This is BERT. By the way, BERT is nothing but bidirectional encoder representation for transformer, where the each word or each token can view all the tokens to the left and to the right, unlike the GPT model. That is, there is no masking here. That is why it is called bidirectional, left and right. Next is the input of our model. The model tries to mainly understand tries to generate the program as in this particular program. For each different question answer, it tries to generate a program. And for this, what it does is there's a generator program. This is the generator program, and it takes the input, and finally let's say it takes the sample input, this interest rate. This sentence is actually present in the pretext itself. That is, it's nothing but it's a collection of the pretext, post text, and table text, and goal indices and all of that, well, goal indices being the supporting facts. And once it takes text as input, it is trained with a program. Uh, it is trained with a program by itself, and then it tries to generate an output program. This output program. In this way, a model is trained to generate a program for every question answer it gets. So finally, when a user gives a question, it can, since it's trained with multiple programs, it can apply the suitable program and give the answer. In this way, a model tries to give the output. Our model can be used by multiple end users like sophisticated professionals or seasoned professionals or financial analysis or etc. And that is my project. Thank you.